All right, welcome to Calc 2. We're going to do a kind of a review video of quiz 2. All right, so let me go ahead and share my screen and we get started. Okay, so quiz 2 is going to have 4 questions on it. Right? Please go ahead and share your work on that and upload your PDFs to the Dropbox. Okay, question 1 is going to be integration by parts. Question 2 is volumes of revolution. Question 3 is a L'Hopital's rule. Okay, and question 4 is improper angles. All right, so let me pause this for a second and get some problems here. All right, so integration by parts, just a couple of different flavors here that you really want to be able to look out for. If I don't want to be too tricky about it, the 2 big ones are you have a polynomial times some kind of a logarithm. Okay. Anytime you have a logarithm, you're probably going to be dealing with integration by parts here. Okay. The other type is some kind of a polynomial, P and Q. Okay, times an E again to some kind of a G of X up here. Okay, where you're going to be realizing that G prime is not G prime of X is not going to be Q of X. Okay, but that's not going to be the case. So it is not a simple U substitution. So let's see what we could do with that. So what if we did some kind of a polynomial about x squared minus 3x plus 1 times the natural log, and we have something in here. How about a 4x minus 1? Okay, and we want to integrate that, and we'll leave it as an indefinite integral. Okay, so this is polynomial times logarithmic. All right, so upon saying this, like, well, we're going to have to do integration by parts. All right, so we pick up our u, we pick up our dv. Okay, now we can't integrate natural log naturally. You know, that isn't one of the easier ones we have. So let's go ahead and make u equal to the natural log 4x minus 1. Okay, what do we have left? We have a polynomial. So this is x squared minus 3x plus 1. Okay, du is equal to 1 over 4x minus 1. But don't forget, there's a chain rule. So we have a times 4 here, okay? And then v, right, is going to be the integral of this thing. That's going to be 1/3 x cubed, okay? Ooh, this might be a little bit harder than I thought. Minus 3/2 x squared plus 1, plus x rather. We'll save the c until the end, okay? Nope. You're going to need partial fractions for this one. Let's not do this one. Okay, fortunately, the one I picked for your quiz is not quite so hard. We get rid of this minus 1 here, then everything will work out. So let's just change the problem a little bit to one that we can solve, and let's just do that. Okay, so my u is going to be natural log of 4x. Okay, remember we're getting rid of that minus 1 so we can do the problem. And then here we're going to have 4x times 4. Okay, so the only thing we got rid of was we made it a problem we can solve rather than a problem that we would need to do like polynomial division on in order to fix all of this, because the book does not ask you to do something anywhere near that hard. All right, so here's our box, right? uv minus v du. All right, so here we have uv minus integral of v du. That's what we're doing next. Okay, so what's my uv? My uv is x squared, I'm sorry, 1/3 x cubed. So is that? I usually try to write the polynomial first. So 1/3 x cubed minus 3/2 x squared plus x. That's uv times natural log of 4x. Okay, minus integral of v 1/3 x cubed minus 3/2 x squared plus x times 1 over 4x, right? So we have to go through and evaluate this piece here, okay? We're not going to touch this. This part has already been integrated. We're done, okay? This part is safe, so we're not going to touch it, okay? It may not look great, but we don't have to do any calculus on this, so we're done with this part, right? So thank goodness. Then we have natural log of, if I know this is going to be like this straightforward, I think I would have asked you a harder question. All right. So let's go through and do this, right? We have 1 over 4x times all of this. So this is going to be integral 1 over 4 times 3, that's 12. And we have x cubed over x, that's x squared, right? X cubed over x squared. Minus 3, 2 times 4 is 8, x squared over x, that's just going to be x. And plus 1/4, and then the x's cancel. And that's what we have to integrate. Okay, this is not a bad integral, is it? Okay, so this is 1/3 x cubed minus 3 halves x squared plus x ln 4x minus, and then we have 1/3, so we have 1/12 times 1/3 x cubed minus 3/8 x squared over 2, okay, plus 1/4 x plus c. Don't forget. All right, let's put this together a little bit more. So we've got 1/3 x cubed minus 3 halves x squared plus x parentheses natural log of 4x minus 12 times 3 is 1 over 36 x cubed. 8 times 2 is 3/16 x squared minus 1/4 x plus c, and you are done. That's it. Okay, that is how you integrate that. Same idea for an exponential, okay? Exponentials can be a little bit longer, so let me take a real easy one just to show you. We have x squared e to the x, and I want to integrate. Okay, so let u is equal to x squared, dv is equal to e to the x. Okay, actually, let's put a 3 in here just for the sake of, so let's put a -3 in here to make it interesting. Okay, so dv is equal to x e to the x to the -3x, right? du is equal to 2x, v is equal to -1/3 e to the -3x. The way I'm going to check this, okay, is I'm going to take the derivative of this in my head to make sure I'm getting back the same thing. So we have the derivative of this is e to the -3x times its chain, which is -3, -3 over 3, it's 1, negatives cancel, we're set. Good. All right, this comes by, right? So our interval is going to be x squared, -1/3, fix that in a minute, 3x, okay, minus integral -2/3 x 2/3 to 2/3. Tell your sister Mary Agony would be so proud of me for messing up my handwriting. It's a consistent problem. Okay, so 1/3 x squared e to the -3x. That's better. Don't be a star yet, but we're getting there. Okay, so that's our 2/3. We factor that out. We have x e to the -3x. Can you integrate this off the top of your head? No. So guess what we get to do? Integration by parts again. Okay, and so this is u is equal to x, du equals dx, dv equals e to the -3x, v equals, we just did this, 1/3 e to the -3x. Okay, so next part is we still have this -1/3 squared e to the -3x plus, and here we have 2/3. Okay, and we have to integrate this part, so 2/3 times, right, because this integral uv minus v du. Okay, I always try to drop it in like this kind of a box format, so I don't have to memorize the formula. I just know it's the diagonal and then across. Okay, so it's going to be negative 1/3 x e to the negative 3x. Okay, that's this times this, minus integral, okay, of negative 1/3 e to the negative 3x dx. Okay. And then we have to integrate this. This one we can do because there's no x's next to it. We can do this one. All right. So this is going to be negative 1/3 x squared e to the negative 3x plus. These guys have to multiply together, so I didn't really mean must. Plus, I meant minus. 2 over 3 times 3 is 9x e to the negative 3x. That takes care of the negative sign, right? And then we have plus integral. We have 2/3 times 1/3. Okay, because we have to FOIL this through. Don't forget that that's the most common mistake people make. Okay, they don't FOIL that. So it's, oh, we have a minus. No, we don't. We have a plus. Okay, 2/3, and then this 1/3 here. Took care of that. This is just negative e to the negative 3x dx. All right. So we have negative 1/3 x squared e to the negative 3x minus 2/9 x e to the negative 3x minus, what is this? This is going to be 2/9, right? And then what do we have? We have e to the negative 3x times 1/3. The negative happened this integral here. Plus c, right? So putting all of this together, x squared e to the negative 3x minus 2/9 x e to the negative 3x minus 2/27, okay, e to the negative 3x plus c, and that is our answer, right? So you're not just, you know, it might take you more than one time to get through all of this, all right? But that's the way that the integration by parts work. There's something called tabular integration, which is a little bit of a shortcut to doing all of this. If I'm not going to show it to you, there's plenty of YouTube, other teachers that will show that. The reason why I don't is because in the past, students have used this for everything. Okay, so it's not off the table. If you want to look it up and use it, you can. But I urge you to practice with this before you decide, this is the shortcut. I'm just going to always use this technique. Doesn't always work. Okay, it works for some things. If you're clever, it'll work. But if you're, if you're having a tough time with integration, I would recommend writing it all out so you don't lose pieces. Because tabular integration, you do tend to forget some pieces and lose them. And then you also use it sometimes when you really ought not to. Okay, so careful with this. All right, that's why I don't show it. Is because the last time I showed it, everybody did it and they applied it to completely the wrong things. It was like, no. So I don't teach it that way anymore, simply because of that. All right, now we're going to do volumes of revolution. Okay, so remember what we're doing, all right, is we're taking, and we've got our calculus potato here. So what we're doing is we're taking a small dx here and we're rotating it around, okay? So we're going to go ahead and make a cylinder out of it, right? And we're going to add up the cylinders. So the way we add, integral, right, because that means sum. And then we have pi r squared h, right? That's our volume of a cylinder, okay? The cylinder. So this is pi. What's our r? Our r is the y value here, right? That's their f of x. So it's pi f of x squared, and then the dA, right? We're adding up a cylinder this way. So the h is really the length of the cylinder. So that's our dx's because we're adding all of this up. Okay. So first off, it's going to be an A to B. Okay, I apologize. You're going to have to memorize this formula. Okay, so know this. So we're going to say this is V is equal to pi integral from A to B f of x, because the pi is a constant, so we keep that out, and then dx. Don't forget to square it often. These problems are written in such a way that squaring it makes it easier, okay? So be careful about that. Make sure you're squaring it. Just as a heads up, what happens when you square root, right? We just get x. What happens if you square like an e to the 2x and I square it? When you raise an exponent raise it to another power. So remember, you have r raised to the s, a to the r raised to the s. What's the rule? This is a to the r times s. So we multiply. This will be e to the 4x. Okay, so be careful about that. I will try to do these kinds of things to you to kind of remind you of some of the math that you've forgotten. So remember this rule, it's important. Remember it applies here too. Okay, that's different than like e to the x squared. That's something you can't integrate. So if you find yourself in this position without any kind of a new substitution down here, that you've made a mistake, because I generally will not ask you that without some warning. Okay, this is a thing. Actually, that's a thing. But without warning that this is going to happen, I won't ask you this question. So you simply can't do it. Okay, the engineering kids can't do it either. Okay, it's not a fundamental form. Okay, so let's find us a problem and we'll do that. So I'm going to go ahead and pause this. All right, let's do two of them. So let's do the volume of revolution of e to the negative, how about we do x over 3, okay? So we'll say f of x equals e to the negative x over 3. We're going to have, what is this going to look like? It's going to look something like this, right? Okay, that's what e to the negative x looks like. And let's go from x equals 0, that's here, to x equals 6, somewhere here, okay? So we're taking this, excuse me, and we're rotating it around, okay? That's the kind of question your book is going to ask, all right? So let's go integral from 0 to what? 0 to 6, okay? We have pi f of x squared dx. So we're going to have pi integral 0 to 6 e to the negative, what is this, x over 3, did I say? Negative x over 3 squared dx, which is pi 0 to 6 e to the negative 2/3 x, because that's what we do, right? We multiply the things here, okay? Yes. All right, 1 second. All right, so that's our setup. All right, now do you need a new substitution for this? Not really, but let's go ahead and use it. Okay, we'll say let u is equal to negative 2/3 x, right? This will be a quiz, and it's you know, might be a little intimidating. Okay, now when u equals when x equals 0, what's u equal to? It's negative 2/3 times 0, which is 0. Okay. When x equals 6, u equals negative 2/3 times 6, right? So that's equal to negative 4. So when I go to do my integral here, we've got pi integral from 0 to negative 4, because that's our u, we're in the u world now. This is e to the u, okay? Du. Oh, not quite. Right? We need to make sure that we have put in, right? We have negative 2/3 dx here. I can't go multiplying things around by negative 2/3, right? You're not allowed to do that. But what if I go ahead and do this and say 3/2? So if I multiply this times this part, right, that's going away. So this is equal to negative 3/2 integral 0 to 4 e to the u. Now, what is negative 2/3 dx, right? Isn't that over here? Isn't that du? There's my du. Okay. So we're going to go ahead and integrate this. The integral of e to the u. So we have negative, so I forgot my pi, negative 3/2 pi e to the u from 0 to negative 4. All right. Now, the other thing I'm going to do here is I'm going to swap my limits of integration. So we have 3/2 pi e to the u from negative 4 to 0. What happened to the negative? Well, if you swap the limits of integration, your negative disappears. Okay, you can use the negative to swap these. Okay, that consumes it. So we have 3/2, okay, pi. What is e to the 0? It's 1. So this is 3/2 pi. We have 1 minus e to the negative 4. Okay, and that would be my volume of revolution. All right. Let's try one that's a little harder. Okay. What if we want the volume of revolution of ln x from, let's go from 1 to, again, let's just choose 6, all right? 1 to 6. Why can't I use a 0? Try to take the natural log of 0. Don't work. Okay. So what am I doing? I'm getting natural log is 1. Something like that. We're revolving this around the x-axis here. Okay. In engineering class, you revolve it around this axis too. There's other methods. This is just a taste of it. Okay. And it's hard enough. You know, the people even when the engineering students get this, like this one is pretty straightforward. They're happy with it, but the other techniques of revolving around, it is not a fun section for anybody. Okay, so if you're feeling like a little like, wow, this is weird, you are not alone. Okay, so we're going to go from pi 1 to 6 of ln x, but what do we have to do? We have to square it. Okay, dx. Now this makes this a much harder problem. Okay, so if you forgot to square it, you'll be in for an easier time. Squaring makes it a little bit harder. Not terrible, but a little bit. Now there's a difference, right? ln x squared versus ln x squared. This you can simplify, right? This is 2 ln x. This one you can't simplify. Unfortunately, this is the species we have here. Okay, you don't get this one, you get this one. Right? So, how do we integrate natural log? Integration by parts. I knew you'd ask. So what we're going to do is we're going to say let u is equal to ln x dv is equal to dx. Now, unfortunately, with integration by parts, all the pieces have to be used up. So we either need a natural log over here, which I don't want to integrate, or we need the whole thing over there. I could take this derivative, right? Chain rule, right? The 2 comes down in front, 2, natural log x. This comes into a 1, so we won't have to write it. And then it's chain, right? We have to do chain rule, so that's just 1 over x. Integrate dx, we get x. All right? So remember, it's across, diagonal, and then across. Okay? So this is going to be pi. Okay? Now we're going x ln x squared minus, and then multiply this across. So minus integral, we have 2 natural log x, and then we have 1 over x times x dx. This bit here, that's a 1. So we don't need that. Right? This is going to cancel. So we can do that. And now where are we? Okay. So we have pi x ln x squared minus 2 integral natural log x. Oh joy, we get to do integration by parts again. Don't assume that just because we're doing it twice, a few times here, means you're always going to be doing it twice on the exam. Okay, that would be a really long exam. I just want to show you this is the worst case scenario. Okay, natural log x dx. So u is equal to ln x, dv is equal to dx, and we need to practice. du is equal to 1 over x, v is equal to x. So uv, x ln x minus integral x times 1 over x, because it's times 1 over x dx. Again, right, this bit here, x times 1 over x, what is that? That's just 1. Okay, so we're going to end up with x ln x minus x, and that's, well, we don't really have a plus c because we have a definite interval, so let's use that. Okay, so let's go back up to here, So we have equals pi x ln x squared, we're stuck with that, minus 2. What was the integral of natural log x? It was x ln x minus x. All right. Now what are we going to? We're going from 1 to 6. Okay. So let's untangle this a little bit. So we have let's just do it. We have pi. We have x ln x squared minus 2x ln x minus a negative plus 2x, right? And we're going from 1 to 6. Okay, we're almost done. Okay, all we have to do is plug in 6, plug in 1, and that's it. Okay, so we're going to have pi. Okay, this is 6 ln 6 squared minus 2 times 6 ln of 6 plus 2 times 6. All right, this is x evaluated at 6 minus, okay, minus down here. Okay, sorry, don't do this. Okay, so we have the pi outside. So here we have 1 times ln of 1 squared minus 2 times 1, that's x equals 1, ln of 1, okay, plus 2 times 1. This is x evaluated at 1. All right, so we have pi, and we have 6 ln of 6 squared minus 2 times 6 is 12 ln of 6 plus 2 times 6 is 12. Okay, minus, what's the natural log of 1? Natural log of 1 is 0. That's 0. Natural log of 1 here, that's 0. So 1 times 0 minus 2 times 0, we just have a minus 2. Okay, so we have this minus here, 2. Right, so just to simplify it down, take it all together here, we have 6 ln of 6 squared minus 12 ln of 6 plus 10 pi. There's your answer. I'm sure that this is a delightful number, but that's as much of it as we have to say. Okay, that's it. We're done. So that is a volume revolution. I did 2 of them. One pretty tame, one pretty scary. Yours is in between. Okay, so not as bad as this, not as easy as the first one. Yeah, I'm going to cut us here, and then we're going to do the next bit. Okay, so we're going to say stop, and then I'll finish up. So, and